Hello everyone, I am Disha from Sri Venkateswara College of Engineering. In this video, we are going to see about performance analysis of algorithms. So the content covered in this video are introduction to the performance analysis, performance dependency, usage of the computer memory, space complexity, examples of space complexity, time complexity, and the examples of time complexity. Performance analysis. So the performance analysis is defined as the process of making an evaluative judgment about an algorithm, or in terms of resources, we can also define it as the process of predicting the resources which are required to an algorithm to complete its tasks. And we need this performance analysis because it helps us to select the best algorithm out of many which are required to solve the problem. That means that when we have a multiple algorithms to solve a problem, we need to select the best out of it and we compare this algorithm with each other which solve the same problem in order to choose the best one. So the parameters on which we choose the best one are memory space that the algorithm takes and the speed of execution and the time it takes for the execution of the problem and also the easiness to understand and also easiness of implementation. The performance analysis of an algorithm depends on the some of the elements such as whether the algorithm is able to give an exact solution that is required for this given problem, then how it is easy to understand and how much easy it is to implement the algorithm. Then it also depends on the how much space it requires for solving the problem and how much time does it consumes to solve the given problem. When a program is under execution, it uses computer memory for three reasons, such as instruction space, where the memory space is used to store the compiled versions of the instruction. Next is environmental stack. Here, the amount of memory is used to store the informations of the partially executed functions during the time of the function call. During the function call, the problems may be solved partially and the obtained results are stored in this environmental stack memory space for the further usage. Then we have the data space. It is the memory space where we can store all the variables and the constants of the given problem. What is space complexity? The space complexity can be defined as the amount of computer memory that an algorithm requires to complete its execution. So when we design an algorithm to solve the problem, it needs some of the computer memory space to complete its execution. And why do these algorithms require the computer memory space is that to store the program instruction, to store the constant values and to store the variable values and also for few other things like function calls, jumping statements, etc. If any algorithms consumes a fixed amount of space for all the input values, then that space complexity is said as constant space complexity. So let us have a simple example to understand this concept. The function of squaring a number has been created here, where the function is passed with the parameters of integer a and it performs the task of squaring a number. In the above piece of code, it requires 2 bytes of memory to store the integer a and another 2 bytes of memory to store the written value of this integer a. This means that totally it requires 4 bytes of memory for the execution and this types of memory is fixed for any type input values. This space complexity is said as constant space complexity. If an amount of space required by an algorithm increases with the increase in the input value, this type of space complexity is known as linear space complexity. So let us understand this with an example. Here the function sum is passed with the parameters such as array of numbers and the number of items in the array. Then the function is going to perform a sum of n numbers. In the previous code, it requires n into 2 bytes of memory to store the array variable and n into 2 bytes of memory to store the parameter n, then 4 bytes of memory for local integer variables sum and I, 2 bytes each, and 2 bytes of memory for returning the value. That means totally it requires 2n plus 8 bytes of memory to complete its execution. Here the total amount of memory required depends upon the value of the n. As n value increases, the space required for the algorithm also increases proportionately. This type of space complexity is known as linear space complexity. What is time complexity? The time complexity is the total amount of time required by an algorithm to complete its execution, and the running time of an algorithm depends upon whether it is running on a single processor machine or multi-processor machine, whether it is a 32-bit machine or 64-bit machine, read and write operations speed of the machine, the amount of time required by the algorithm to solve the problem, and like and perform the arithmetic operations, logical operations, return the value, assignment operations, etc. And mainly the execution time depends upon the input data that an user gives. If any program requires a fixed amount of time for all the input values, this type of time complexity is known as constant time complexity. So let us consider a simple example to understand this. Function with sum is passed with the two parameters integer a and integer b. This function performs the task of adding two integer values and returning it. So in the above example, it requires 1 unit of time to calculate the sum and 1 unit of time to return the value. This means that it takes 2 units of time to complete the execution, and it does not change based on the input values of the integer a and integer b. For all the input values, the time complexity remains the same. So this is what is known as constant time complexity. In contrast to the constant time complexity, we have linear time complexity as well, where the input values will determine the amount of time taken by an algorithm to complete this execution. So here is an example with an function named called sum, which is passed with an integer array and an integer n. In this code, the function performs the task of sum of n arrays, and it requires 4n plus 4 units of computer time to complete the task. Here the exact time is not fixed and it changes based on the n value. If we increase the n value, the time required by the algorithm also increases. So totally it takes 4n plus 4 unit of time to complete the execution, and this is known as linear time complexity. Thank you for watching this video. Please to like, share and subscribe.